All right, this is another part of, I don't know, we don't actually read this part 2 up here, do we? Let's just look at it this way. It's the properties of exponents. I'm going to talk about properties of exponents, and I'm going to talk about, in this lesson, how to simplify expressions with negative exponents or an exponent equal to 0. So we'll be looking, you'll be, at the end, you should be able to simplify these kinds of expressions. 2x to the 0 power, 3 over z to the negative 4, x to the negative 4, and so on. All right, this is going to build on the previous lessons, the quotient rules, the product rules, and all those. There's going to be 2 or 3 things at the end you probably just want to memorize. They're not that complicated, so it shouldn't be too bad. But unlike the other ones where I say, oh, just derive the rule if you forget, these ones you probably want to memorize. So let's start with this. What is 4 divided by 4? Well, you can do it on your calculator if you want, but hopefully you don't have to. 4 divided by 4 equals 1, right? Okay, we're all agreed on that. What about this one? 267 over 267. Again, don't do it on your calculator. Make me happy. Say, oh, well, that's got to be 1. Why is it 1? Well, because anytime you take some number and divide it by itself, you get 1. Okay? Same thing here. It doesn't matter if it's a variable. Any number, right? So any x, anything I put in here, as long as I put the same thing in here as I put down here, x over x is going to equal 1. And it doesn't matter if there's exponents, anything. I take some number and I take it to the 5th power, take the same number and take it to the 5th power again, divide it. I'm going to have 1. Anything divided by itself is 1. In any number, there's exactly 1 of that number. Think of it that way. Okay, we're all good on that? All right, well, let's go back to what we talked about yesterday, the quotient rule for exponents. We said that the quotient rule told us that x to the m, some x to some power, divided by x, that same x, to some other power, n, would equal x to the m minus n power. We subtract the exponent in the denominator from the exponent in the numerator. Well, how would that apply to this problem? Well, x to the 5th divided by x to the 5th. Well, x to the 5th divided by x to the 5th. So we've got, here's our m, and here's our n. So it would be m minus n, 5 minus 5. What's 5 minus 5? 0. So we would have x to the 0 power. And we already said, though, that x to the 5th over x to the 5th equals 1, right? Can we say that? Yeah, anything over itself is going to be 1. So anything divided by itself will be 1. So what it looks like is we've got, well, if x to the 5th over x to the 5th equals x to the 0 power, and it equals 1, well, that suggests strongly that x to the 0 power equals 1. You've probably seen this before. But this is called the zero exponent rule. Some number to the 0 power is equal to 1. And it doesn't matter what it is. It could be anything. Anything to the 0 power is going to be 1. Let's look at that a little more closely. Okay, so what are some examples? Okay, like first example, I've got z to the 0 power, right? So that's going to be what? That's going to be 1. 4 to the 0 power. Anything to the 0 power is 1. So 4 to the 0 power is 1. Oh, now this one's different. This is weird. X plus 2y to the 0 power. But it doesn't matter, right? It's anything, this whole thing. It doesn't matter what that comes out to. Take it to the 0 power, you're going to get 1. Same thing here. You throw in some powers, 4x squared. All of that to the 0 power. Remember, these parentheses mean this whole thing is going to the 0 power. So that whole thing to the 0 power, that's going to be 1. What about I take Barack Obama's left elbow, and I take that to the 0 power? It doesn't matter. Left elbow, right elbow, patella, foot, ankle, it doesn't matter. Take that to the 0 power, and I'm going to get 1. So get that stuck in your head. Anything to the 0 power is 1. That's one of those things you're going to want to memorize. All right. Well, let's talk about negative exponents. This came up actually in class, but let's see where these things come from. So take something like this. X cubed, x to the 3rd power, divided by x to the 4th. Well, our quotient rule says what? It says x to the m divided by x to the n equals x to the m minus n. So this is m. This will be our n. So this should equal x to the 3 minus 4. Be careful. It's the exponent in the numerator minus the exponent in the denominator. Don't put the bigger number first. Put the numerator minus the denominator. The exponent in the numerator minus the exponent in the denominator. 3 minus 4. What is 3 minus 4? Not 1. It's negative 1. Ooh, that's weird. So it looks like we get these negative exponents. What is that? What could that possibly mean? Well, to figure out what that could mean, let's go back to the way we did this before. When we were doing these exponents, and I was showing you the quotient rule, and we were just factoring it all out and canceling common factors. Let's do that here with the same problem, x to the third over x to the fourth. So x to the third is x times x times x. X to the fourth is x times x times x times x. Okay, we start canceling things out. Well, these two cancel out. These two cancel out. These two cancel out. Remember, these cancel out because x over x is 1. We're using that again, right? X over x is 1. Anything over itself is 1. So what are we left with? Well, it looks like maybe we're left with nothing up here, but remember what we said. That's the same as x times x times x is the same as x times x times x times 1. So we're still left with 1 on the top. And what are we left with on the bottom? Well, just this 1x here. So we get 1 over x. Oh, let's use that same reasoning we did in the last problem. We said x to the third over x to the fourth equals x to the negative 1. That's what we got by this reasoning, using that quotient rule. Over here, we got x to the third over x to the fourth, same thing, but that it equals 1 over x. Well, if x to the third over x to the fourth equals both of those things, then those two things better be equal to each other. So x to the negative 1 power equals 1 over x. I can't emphasize how important it's going to be that you memorize this, that you just know this. Because time and again it's going to come up, and every year people are confused and surprised again and again to see that x to the negative 1 is 1 over x. So get the jump on it and just get this, solid in your memory. X to the negative 1 power equals 1 over x. All right, so let's look at another one. Let's look at one that's a little bit different, but the same idea, right? We've got x squared over x to the fifth. Well, by our quotient rule, that should be x to the 2 minus 5. 2 is the exponent in the numerator, 5 is the exponent in the denominator, and that gives us 2 minus 5 is negative 3. So we end up with x to the negative 3 power. What does that mean? Well, let's see. Let's try it by cancellation. Same thing we did before. Well, x squared is x times x. X to the fifth is x times x times x times x times x. We cancel out the common terms here. So cancel out this pair of x's, cancel out this pair of x's. What are we left with on top? We're left with that times 1. Don't forget our times 1. Okay, so what do we get? Well, 1 over x times x times x, or 1 over x cubed. Oh, well, take these two things and pull them together, right? We've got the same problem, x squared over x to the fifth and x squared over x to the fifth. On the one hand, we said it equals x to the negative 3. On the other hand, we said it equals 1 over x cubed. Well, if it both equals both of those things, again, those two things better be equal. So x to the negative 3 equals 1 over x to the third power. Okay, now we can start to make a more general claim. And this is probably something you want to keep in mind too. That x to some negative power, x to negative anything, negative n, is going to equal 1 over x to the n power, to the positive n power. So when we go from here to here, we shed the negative, but we put x to that n power in the denominator. Okay. Some examples here. So we've got x to the negative 6 power. Well, that's going to be 1 over x to the 6th power. 3x to the negative 2 power. That's this whole thing to the negative 2 power. So we're going to take that whole thing, which is 3x, right, and 1 over that whole thing to the 2nd power. So 1 over 3x squared. Remember, this exponent being outside the parentheses means it applies to this whole thing inside. And then we could say, well, using our power of products rule, we could say that equals 1 over 3 squared times x squared, because then this exponent applies to each thing inside, or 1 over 9x squared. 2 to the negative 3 power, that's going to be 1 over whatever's here to this power, 2 to the 3rd power. And if you like, 2 to the 3rd is 8. You can write it like this, but either way, 2 to the negative 3 power equals 1 over 2 to the 3rd power. One last case. Okay, what about this one? 3 over x to the negative 2. Now the math is going to get a little weird here. You may just want to end up memorizing this one. But 3 over x to the negative 2 power. Well, x to the negative 2, we know, is 1 over x squared. So this, different color, 3 over x to the negative 2 should be 3 over 1 over x squared. That looks ugly. But remember, 3 over this is the same as this, the numerator, divided by the denominator. So maybe we can think of it that way. 3 divided by 1 over x squared. Now, I don't know if you guys remember the rules for dividing fractions. When you divide a fraction, you multiply by the reciprocal. So this is the same as 3 times x squared over 1, which is 3. Well, x squared over 1 is just x squared, so 3 times x squared, or as we would usually just write it, 3x squared. So what happened? Well, to put it loosely, we took this x to the negative 2 power, just like over here we took the x to the negative 2, made the exponent positive, and moved the whole thing into the denominator. We've got the x to the negative 2, it's already in the denominator. We're going to make the exponent positive and move the whole thing up into the numerator. And that's what we did. We ended up with 3x squared. So here's another rule. This one's harder. You're just going to have to remember this one. A over x to the negative n power is equal to a times x to the n power. All right, so let's look at some examples of this. So y to the negative 4th, right? Well, we're going to take this whole thing and bring it up and make this exponent positive, so we end up with 2y to the 4th. 1 over z to the negative 8 will bring this z to the 8th up, right? We make the exponent positive, bring it up, so we have 1 times z to the 8th power, or we'd probably just write that z to the 8th. And 3 over 2 to the negative 3 power, that's going to be 3 times, oops, that's not a 3, 3 times 2 to the 3rd power. So 3 over, sorry, I think I said that wrong. 3 over 2 to the negative 3 power is going to be the same as 3 times 2 to the positive 3 power, 2 to the 3rd. And you could, if you want, that's 3 times 8 or 24. But this is the main thing, 3 times 2 to the 3rd. All right. Things you probably want to memorize, so this is just a recap. X to the 0 equals 1. X to the negative n equals 1 over x to the n. And any number a over x to the negative n power is going to equal that number a times x to the positive n. Okay, a couple of practice problems. So why don't you try these now? I would suggest that you pause the video, try the problems, and then come back and I'll show you the answers. Okay, so here's the answers to these practice problems. 2x to the 0 power. Well, anything to the 0 power is 1. So it's just 1. This one, 3 over z to the negative 4th. So we're going to bring that z to the 4th up. We're going to bring this up and make the exponent positive. So we end up with 3z to the 4th power. X to the negative 4 power. Well, that's the same as 1 over x to the 4th. Now we take it from the numerator, and put it in the denominator. Okay, and then here, number 4, well, this is tricky. There's a couple ways you could do this, but the simplest way is just to remember anything to the 0 power equals what? 1, right? So it doesn't matter what's inside here. If that 0 is sitting on the parentheses, then whatever's in the parentheses here is just 1. Just becomes 1, and you're done.